Example 2. Find the zeros and give the multiplicity of each. Sketch a graph. We're going to put all of the components together that we've learned so we can get a rough sketch of what a picture of this graph might look like without using graphing software. Let's start by finding the x-intercepts. We're going to set this equation equal to 0. You'll notice that we have each of these components, each of these factors are repeated twice. That means that the multiplicity of each of those zeros or x-intercepts is equal to 2. So we're getting that if we split this into two different equations, we have that 0 is equal to x plus 2 squared, or 0 is equal to x minus 3 squared. Technically, we could take the square root of both sides and we would just have x plus 2 equals 0 and x minus 3 is equal to 0. So this first one tells us that x is equal to negative 2, and this one tells us that x is equal to 3. And again, the multiplicity for each of these zeros is equal to 2. That 0 is repeated twice. This is going to make a difference in what happens at the x-axis when we graph that particular x-intercept. What else do we know? Well, we can find the y-intercepts. Let me write these as points. Let me go back to the x-intercept. I want to write this as negative 2, 0, and 3, 0. Let me put some, we're going to come back and use this in a minute. Our x-intercept, if we plug 0 into the, or sorry, our y-intercept, if we plug 0 into the equation there, we'll get 0 plus 2, the quantity squared, and 0 minus 3, the quantity squared. So this is 4 and 9, so it looks like we're getting 36. So 0, 36 is going to be our y-intercept. Okay. We also know we can think about the end behavior by looking at what the overall degree is. If I were to multiply this out, I would get x squared from this term and x squared from this term. So I think that the leading term is going to be x to the 4th power. So that means that my graph is going to look like this at the extremes. As x goes towards negative infinity, my y values are going towards positive infinity. And as x goes towards positive infinity, my y values are also going towards positive infinity. For the number of turning points, that's going to be 3 or less. Remember, we go to the degree of the overall polynomial and we take 1 off of that. So it could be 3 at the most, but it might be less than that. All right, let's put this all together in a graph. So again, this is just going to be a rough sketch. We've got x-intercepts at negative 2 and positive 3. We know that the end behavior is going up on both sides, right? So I'm going to just draw some arrows here. And our y-intercept is at 36. This isn't going to be drawn to scale. I'm just going to put 36 here and say that that's where our graph is going to go through. So what's going to happen now is I need to take the multiplicities into account. When a graph has a multiplicity that is even, the graph is going to look like a parabola right at the x-axis. It sort of bounces off the x-axis. Since the graph is above up here, when I get to this 0 at negative 2, the multiplicity is 2, so that means that the graph has to sit and just bounce off the x-axis here, not go through the graph. If the multiplicity is odd, then the function will go through the x-axis. So it looks like I'm going to come back up here to 36 and then turn back around because I've got to get to this 3 over here on the right, and the multiplicity there is also 2. So it's going to bounce off the x-axis and then come back up here. So kind of putting this all together, I think that my graph is going to look something like this. Kind of putting all those components together. Let's look at another example. In this example, we've got, again, this is already in factored form, just to make it a little easier on us. Let's find our x-intercepts to start. We're solving the equation 0 equals x squared times 2x plus 3 to the 5th power and x minus 4 squared. So we're going to split each of these into separate equations. And then x minus 4 squared is equal to 0. Okay. No, I write this so close together. All right. For the first equation here, if I take the square root of both sides, I'm going to get that x is equal to 0. For the second one, I'm going to take the 5th root of both sides, and I'll get that 0 is equal to 2x plus 3, or negative 3 halves is equal to x. And then for the third, I'll take the square root of both sides. We have that 0 is equal to x minus 4, or 4 is equal to x. So my x-intercepts are 0, 0, negative 3 halves, 0, and 4, 0. And the multiplicities for them are 2 for this one, 5 for this one, and 2 for this one. So the behavior at the x-axis is going to be that it's going to bounce off the x-axis for this and here. But for 5, it's going to go through the x-axis. All right, let's find our y-intercept. Our y-intercept, I think, is just going to be 0, 0, because if I plug 0 in here, the whole thing's going to be equal to 0. So we've got this. We've got these here. What about our end behavior? What's the degree of this polynomial? I would have something squared. Let's see. My leading term is going to be x squared. And then I have this 2x raised to the 5th power from here. And then I have an x squared from here. Let's see. 2 to the 5th power is 32. So I'm going to get 32 x to the, let's see, is that going to be 9? X to the 9th power. So this is going to act like an x cubed graph. We've got a positive coefficient and the degree is odd. So we think that as x goes towards negative infinity, our y's are going to negative infinity. And as x goes towards positive infinity, our y values are also going towards positive infinity. We're going to have at most 8 turning points. I don't think we're going to have that many because we've got so many multiplicities there with the x-intercepts. All right, let's put this all together and see if we can get a rough sketch of a graph. So I'm going to space this out a little bit. We've got a 0, an x-intercept at 0, 0, and then at negative 3 halves. So here, and then 4 here. The y-intercept is also at the origin. We said that our end behavior is going to be going up on this side and down on this side. Now we'll take the multiplicities into account. when our x-intercept was -3/2, we have that the graph is going through the axis, so it's going to look like this. So I think I'm going to be coming from down here, and then it's got to turn around somewhere to get back to the origin. The multiplicity there is 2, so it's going to bounce off the axis here. So we don't know where, but we're going to use calculus later to figure out where this turning point is. And then when we go, we've got to get over to 4 over here. The multiplicity here is also 2, so it's going to bounce off the axis here. So I think my graph, I don't know where this turning point is, but it's going to be somewhere. We can, again, later in calculus, we learn how to figure out where that turning point is. But this is what our graph is going to look like roughly. All right, let's do one more example. So let's find our x-intercepts first. We're going to have from our first factor here that 0 is equal to x cubed, or from our second factor, x minus 1 cubed is equal to 0. And then from our third, we'll have that x plus 2 is equal to 0. So we're going to get that x is equal to 0, or x is equal to 1, or x is equal to -2. And the multiplicities of each of these, this 0 is 3, this one is 3, and this one is 1. They're all odd, so the graph is going to go through the x-axis at all of these points. What's our y-intercept? Well, since we're getting 0, 0 for one of our x-intercepts, that's also going to be our y-intercept. When we plug 0 into this function, we're going to get 0, 0. So our y-intercept is the same as our x-intercept. All right, what is the degree of this polynomial? Well, if we think about the leading term, we would have x cubed from the first part, and then x cubed again, and then x. So it looks like this is x to the 7th power. So we think that our graph is going to look like this. All right, let's kind of put this all together and see what we think. So I've got zeros at the origin, at 1, and at -2. Our end behavior is, we said it's going to go up on the right and down on the left. And each of the zeros is going through the axis because they're all raised to odd multiplicities. So I'm going to have some turning point here and some turning point here, and it's going to go up and it's going to go down like this. Again, our purpose is just to get a rough sketch of what the graph looks like. And what we care about as we move forward into other applications is where the graph is above the x-axis versus where it's below the x-axis. And these multiplicities can really help us determine when the graph just bounces off the x-axis or goes through.